Central force, motion and law of equal areas. Let us discuss what is actually a central force. There are different forces acting on a body. If the forces acting on a particle is in such a manner that the motion is directed towards or away from a fixed point, such type of forces you call it as central force. You know lots of examples like planetary motion, electrostatic force between two charges, elastic forces, etc. So those are all examples of central forces. Now let us see what are the properties of a central force. In a central force, the torque acting due to the central force is 0. So torque tau equal to R cross F. Here I have put a bar to indicate that this is a vector, because I am using a unit vector and the notations here. So just to remind you that this is a vector. So R cross F bar. R cross F. So this is R cross magnitude of F into unit vector R. Vector R I have written as, vector F I have written as modulus of or magnitude of the force F of R into the direction which is along the direction of R, which is indicated by the unit vector R. So vector R into unit vector R, both are directed in the same direction, so the cross product is 0. So the torque acting due to the central force is 0. That is one property. The second property is the torque, which is equal to rate of change of angular momentum. From this itself it is 0. Torque 0 means angular momentum is a constant. Only when you differentiate a constant you get 0. So due to the torque being equal to 0, we can say that the angular momentum is a constant or angular momentum is conserved. Now angular momentum L is R cross mv. That is m into R cross v. It is a constant vector. Angular momentum is a constant vector. If angular momentum is a constant vector, that implies that R cross v lies in a plane. So if you look at planetary motion, it is moving in a plane. So in central force, the objects will be moving in a plane. The next property of a central force is aerial velocity of the particle moving under central force is a constant. Let us see how it is happening. This is the path of an object moving under central force, moving in a plane. This is particle is moving from point P to P dash. This is vector R. After a time delta t, it has reached point P dash. So here now the vector is R plus delta R. This angle is say theta. And this arc will be the small distance will be r d theta. This is angle theta, this is r, so this will be r d theta. Now the area of this triangle, that means the area swept in the small interval of time delta t, that will be the area OPP dash. You have to find out the area of this triangle OPP dash. Area of the triangle is half base into altitude. Here the base is r plus delta r, base is this which is r delta theta. So the small area of the triangle delta is half base into altitude, half r plus delta r into r delta theta. That is equal to half r square delta theta plus half r delta theta. Delta r delta theta will be a very small quantity when delta theta tends to 0. That is in the limiting case. In the limiting case, when delta t tends to 0, delta a by delta t will be equal to dA by dt. dA by dt is the limit delta t tending to 0, delta a by delta t, which is equal to, the other side also we are applying, limit delta t tending to 0, half r square delta theta by delta t. Delta theta can be neglected because this is a very small quantity multiplied by another very small quantity. So finally what remains is half r square d theta by dt. Now in polar coordinates, velocity of a particle v can be represented as r dot into unit vector r plus r theta dot unit vector theta. R dot is nothing but dr by dt and theta dot is d theta by dt. This you are getting from the polar coordinates r, theta, z. This also you have studied in your plus 2 classes. Angular momentum L. Angular momentum is r cross mv. That is, vector r is magnitude of vector r into unit vector r, this part. Then cross mv. M into, instead of v, we have written r cap plus r theta dot into theta cap. So this is m into, yes. So you look at the first term. First term you take r cap into r cap. R cap into r cap is 0. So you have to consider the next term. You have r cap into theta cap. R cap into theta cap is k cap. So this is equal to mr square theta dot k. So the angular momentum L is equal to mr square theta dot k. That is, this is the k is the unit vector along z direction. So this will be the z component of angular momentum. So Lz equal to mr square theta dot. From that, r square theta dot is Lz by m. So our dA by dt, this half r square d theta by dt is half r square theta dot. So instead of r square theta dot, I can write Lz by m. So dA by dt will be equal to Lz by 2m. Lz is constant in any central force. If Lz is a constant in any central force, that means dA by dt is a constant, or aerial velocity is a constant in central force motion.